All right, the last problem that I'm going to work is from our specific heat section of the dry lab. So the specific heat, I'm going to do number 2. This one I've circled. It says this: the specific heat of fat is 0.45 calories per gram degree Celsius. And the density of fat is 0.94 gram per cubic centimeter. How much energy in calories is needed to heat 10 cubic centimeters of fat from 25 degrees Celsius to its melting point of 35 degrees Celsius? This type of problem tends to give people a lot of trouble. It's actually very similar, if not almost identical. The numbers may be different, but to a problem on your Chapter 1 homework, I believe. So this is a double help working one like this. So I'm going to zoom in so I have some more room. But the reason people don't even know where to start is because you have specific heat and you have density all in one problem, and they don't. It's like, why do I need density here? Well, let's write out the equation for specific heat. If you remember, specific heat equals our energy term, and notice we're working in calories and we want our answer in calories. So I'm going to write calories here per gram times, and this is change in temperature, okay? Change in temperature, not a static temperature. So we will get the change in temperature for that. Now, we have to plug in, actually we're solving for, let's reread the question. How much energy in calories? So we're trying to solve for calories here. So just the way I did in lecture today, we're going to rearrange this equation and get calories by itself. So to do that, I'm going to multiply both sides of the equation by gram times change in temperature. Over here, same thing, gram times change in temperature. And we're going to, these cancel on this side of the equation. So now I'm going to write my new equation, which is this: the mass of fat that I have in grams times the change in temperature that I have of the fat times the specific heat of the fat equals the amount of calories that are needed to heat that fat from the initial temperature to the melting point. So first off, what do I have? What do I need? To solve for calories, I have to have grams. That's the first thing I need. I have to have change in temperature, and I have to have specific heat. So do I have these 3 things? Well, let's read the problem. Here's piece number 3. Okay, so we have the specific heat. Check. What about the change in temperature? 25 to 35. We can calculate the change in temperature. The final minus the initial gives us a change of 10 degrees Celsius. Okay, so that is, here's piece number 2 right there. And so that's a check. What about the mass? Well, let me read. Specific heat of fat is here. The density of fat is here. That's not, this number here is not your mass. Okay, that's your density. So far I don't see mass. How much energy in calories is needed to heat 10 cubic centimeters? So what about this number? Is that a mass right here? 10 cubic centimeters? Look at the units. Is cubic centimeters units of mass? No, this is units of volume. So I don't have a mass anywhere in the problem, so how can I solve for this? Well, that's the reason you're given the density. So if you look at this, what is density? Let's remind ourselves. Density equals mass over volume. Well, I'm given a volume and I'm given a density. Can I solve for the mass? Yes, I can. If we rearrange this equation the same way we did our specific heat equation, we're going to get mass by itself. That's what we're trying to do. So multiply both sides of the equation by the volume. And when we do so, volume has moved to the other side of the equation. So now we find, when we rearrange this, that the mass equals the density divided, or sorry, not divided, times. Density times volume. All right, I have a density and I have a volume. I can get mass, so let's actually do that now. So I'm going to take my density, which was 0.94 grams per cubic centimeter. All right, and I'm going to come right down here. So mass of, we're talking about fat here, equals, I'm going to plug in the density, 0.94 grams. And remember, things that are written with a little slash, I encourage you to write them as an actual fraction with a numerator and a denominator. So that's what I'm going to do, gram per cubic centimeter. And what does my equation tell me? Multiply by the volume. So here's the volume. So I'm going to multiply that by 10 cubic centimeters. Notice that we have cubic centimeters on bottom with the density and on top fat, or the volume, and those cancel out. So now we just do 0.94 times 10, and we get a mass of 9.4. What's our units? The only ones that don't cancel, grams, which is the base unit for mass, so that makes sense. So now I have piece number one. I have all three pieces. So now I can solve for calories. I'm going to do the grams, 9.4 grams, times my change in temperature, which is 10 degrees Celsius, times the specific heat, which is still over here in the problem, 0.45. So I'm going to come over here and do that. So we are going to do 9.4 grams times our change in temperature, which was 10 degrees Celsius, times the specific heat, which was 0.45. And the units there, what were the units? Calories per gram degrees Celsius. All right, so this was our mass, this was our change in temperature, and this was our specific heat. All right, so now do the proper units cancel? Because we need to be left with units of only calories. That's what the question was asking for. How much energy in calories? So let's double check that. Grams cancel because I have them on top and bottom. Degrees Celsius cancels. And the only one I'm left with is, yep, calories. So now it's just a math problem. We do 9.4 times 10 times 0.45, and you should get an answer of 42.3 calories. Okay, that is the specific heat problem that I wanted to work. I hope you find these helpful, and if you have any other questions about this dry lab as you are working it, shoot me an email or reach out.